Have you ever tried to get into asynchronous programming only to get stuck on all the complicated keywords? Or maybe you found out that while it sounded great, you just couldn't get it to work in the real world. Well, in this video, I'm going to show you how to make use of asynchronous programming with very little effort. My name is Tim Corey, and my goal is to teach developers how to learn C# the easy way. In this video, that means I'm going to be skipping all the history of threading. That may interest some people, but it really isn't relevant to what you need to know today. Instead, what you need to know is how to use async and await in the real world to make your apps faster and more responsive. Now, just to be clear about what we're talking about, let's go over what I mean by synchronous versus asynchronous. Synchronous programming is work that gets done in sequence. Task A gets done, then task B, then task C, and finally task D. The problem is that no one else can do any work until task D gets completed. Asynchronous programming allows us to fix that problem. There are two big benefits you're going to see right away when you use it. The first big benefit is in your user interface. If task B takes a long time, that will lock up your user interface. By executing a task asynchronously, while they're waiting to complete, control can be given back to the user interface, so it's still responsive. The second benefit comes into play especially when tasks C and D don't rely on task B. In fact, maybe none of the tasks depend on each other. Maybe they're all just things that need to be done, but we don't need to get data back. In that case, we can execute them in parallel. That means as long as your system has the resources, it will try to do all 4 tasks at once. If each task took 3 seconds to execute, instead of taking a total of 12 seconds to complete, it might only take 4 seconds. Hopefully you at least have an understanding now of what we're talking about. I think it'll get even clearer when we look at the code. Before we do, just a reminder, it'd be great if you could give this video a thumbs up. And also, just make sure you're subscribed to the channel. Okay, so let's switch over to Visual Studio. As you can see, I already have a demo app set up. I wanted to put some of the basic code together that I needed to run the demo, but that didn't really apply to what we're talking about. I'll give you a quick run through before we get started. So this is a WPF application. I just have this one form here for the user interface. It has a couple of basic things on it. It's got 2 buttons, and it's got this results pane down here. Now, you may not be able to see the results pane, but that's right here. It's called results window. So what we're going to do is we're going to execute a task the way we normally would using this button and see the results down here. And we'll see the user interface locks up, and it takes a little while, and it waits to display the information on the screen. And then what we're going to do is we're going to use this button here, the async execute, to allow us to do the same task but asynchronously. And we'll see how we can use the user interface still, and how we can actually even see the entries come in one line at a time instead of all at once at the end, like it does a normal execute. And we'll see all that in a little bit. But that's our basic demo user interface. Now, just a quick disclaimer here. This is a WPF app, and I'm not using MVVM. I usually use MVVM with any kind of real WPF application. But in this case, it's just a demo. The other thing to note is I really don't like the idea of putting code behind your user interface. And the reason why is because when that code sits back there, it can't be used if you go to a different user interface. You gotta kind of extract it and pull it, and it just makes a mess. And so I really recommend you don't put code in the code behind except for what is necessary to get data onto the screen and off the screen. But in this case, again, since it's a demo, I have put all my code in the code behind. So just kind of brace yourself. Don't do this for a real application. It's just a demo. Okay, so the code behind here, I've got a few things already set up. First, I have 2 button click events. The execute sync click, which that's this one right here, and then the execute async click, which will be this one right there. So the execute async is blank right now. Execute sync has some code in it. And what this code does is as follows. First, we've got the stopwatch start new. And so what I'm doing is I'm timing how long this takes. So the way to do that is to start this stopwatch timer. Now you don't want to use a datetime.now and try and grab that because it's not quite as precise. This is much more precise, where we start a stopwatch and then at the very end we stop it. And so everything in between gets timed. And it will say, okay, here's the elapsed milliseconds between this line right here and this line right here, which in theory will record how long this runs for. So there is an even more precise way of doing things if you really want to get down, deep into tracking your performance. But this is a really good performance counter for, general stuff. So that's what we're going to do. We're just going to have this stopwatch start that's built right into the .NET framework. So you don't need any special libraries for it. You just run this line of code here that says start new. Then you run your code. Then you say stop and grab the elapsed milliseconds. So that's all we're doing here. And the last thing we do is we write out to the results window a line that says, here's the total execution time for that action. So in between, there's this one action here called run download sync. So let's look at what it does. We come down here, run download sync says first give me the prep data, which the prep data is just a list of string that has a bunch of websites: Yahoo, Google, Microsoft, CNN, Code Project, Stack Overflow. So just a list of string that it gets back, and it also clears out the results window to start. So once it gets that prep data, then it loops through each website and calls this download website, and it passes in the website URL. So what the download website does is it just creates a new web client, again, built-in .NET stuff, and then it downloads a string that represents the entire index page. Now, the reason I'm using this is because it's a great simulator of us asking for data and waiting for it to be done. Some websites are pretty responsive, some not so much. Now, the other thing I note here is I'm actually building a website model, I call it output, where I put the website URL we loaded and then the actual data we got as well. And I return that set of data. And there's that model right there. Website URL, data. Pretty simple. Just two properties. So the reason I do that is so I can keep the information together. The actual website URL and then the actual data for the site. Now, I don't actually use the data. I just use the length of the data to show me how big the website was in terms of characters. Okay, so back up here, we run the download sync. So run download sync downloads every website, and when it's done, it reports on the website info, and it passes that results in, which is the website data model. So what that does is it just writes out to the results window.txt, it appends the URL and the length of the data. And finally, at the end, it writes a new line. That way we have one entry per line. So that's all we're doing is we're just grabbing a whole bunch of URLs, one at a time, we're downloading them and reporting the information to the screen. Now, that's kind of important. We download one website and we report it on it. Then we go to the next website and download it and report it. So let's see how it actually works. Now, just note, the first time you run this, it's a lot slower than the second time, and that's because it's actually going out and trying to find the proxy settings the first time. After that, it remembers it until the app closes. So the second and third time, it's a lot faster. But we'll execute the first time, and I want you to observe two things. First of all, I'm going to try and move the window after I click this button, and it won't move. And second of all, I want you to see if those lines come in one at a time or all at once at the end. All right, so here we go. Click the button, try and move, nothing happens. And there, boom, all those lines popped in all at once. Total execution time, this is in milliseconds, so it's 2.2 seconds. So there's the websites, there's how long they were. Now notice if you execute a second time, it changes to 1.2 seconds, even down as low as 0.7 seconds. So it gets pretty fast once it gets past that looking for the proxy server. But that's where we're at, somewhere around 3/4 of a second to download these 6 websites. So let's see if we can't do something about these 2 problems. Problem 1, I can't move the window around while it's running. Problem 2 is that these show up all at once at the end instead of one at a time as we get the data back. So let's address problem 1 first, because I'll show you there's 2 different parts to asynchronous, and I want to make sure that we kind of separate them out into their respective parts. So first, let's essentially make a copy of everything that happens in the execute sync click. And copy this whole thing and paste it down here. The one thing I'll change is we're going to run download async. Now that doesn't exist yet, but we're going to create it. So let's kind of minimize some of the other things we don't need. And we're actually going to, again, copy this, the run download sync, and I'll just paste it here and say async. Okay, so we have exactly the same thing as before. If we were to run this, it would run the same way both times. But let's see if we can't make this work asynchronously so that we kind of release that user interface and it doesn't lock up while it's running. Now, if you know anything about the download website method, you'll actually know that down here, there's actually oops, not download website. Here we go. Inside here, the download string for the web client, there's actually a download string async, or task async actually. We're not going to use that yet. We're going to wait. I'm going to demonstrate how to do it if you can't change that. Because sometimes you have other people's code or code that you just can't touch, but you want to have it run asynchronously. And so how do you do that? And so I'm going to go ahead and do that for you, just kind of show you what you can do to make this run a little better, a little bit asynchronous. So what we're going to do is take this line right here where it says, let's minimize this so we don't get confused. This line right here, it says download website and then pass in the site. Let's pretend we don't have control over that, but we want to make it asynchronous. So the way we're going to do that is right here, we're going to say task.run. And what task.run does is it says, I want you to run this stuff in here, inside my parens. I want you to run it asynchronously. Now, what we're going to do is pass open and close another set of parens. So notice 2 opens here. Open, open, close. And then we're going to do a lambda expression. So equals greater than. And say, okay, pass in this code right here to run as our task. All right. Now right away it yells at me. Now don't panic here. Since I'm saying task.run, notice what it's going to return back is actually a task of type website data model. All right, that's this right here. That's the return. So it's going to return a task of website data model, not website data model, which is what we're expecting. So what I've done here is I've kind of wrapped this code in an asynchronous bubble. But now I want to use what's called the await keyword. Now what await does is it says, okay, you need to run this asynchronously, but you need to wait for it. Okay? And the reason why I want to wait for it is because I need to have these results in order to report on them. So I can't go on report on something that I don't know the results of yet. So we have this await keyword. Now it's still yelling at me, but the reason why now is because it's saying you can't have an await operator unless it's an asynchronous method. The way you change that is you say async up at the top. Now it's all good. Now here's one tip right away. And don't worry if you starting to get lost a little bit. We're going to go over all this over again. But I want to get it all out here first. So, real big important tip here. Don't return void from an asynchronous method. If you don't have anything to return, don't create something. Just say task. Okay? Now, if you do have something to return, say it was actually returning a string, what you do is just say task of type string. And now that's saying this is going to return a string. So return, yep, or whatever. And that works now. Because return a string, you don't have to worry about wrapping in task. That's taken care of by this async. But in our case, we don't have a return type. It was returning void. So now we just say return task. Okay? So make sure it does not return void. Now there is one exception to that, and we'll see it in just a minute, but anytime you have an event, you can't change an event from void to task. It doesn't work that way. So you have to leave it at void, and that's okay. That's fine. That's the one exception that C# knows about and is fine with. All right, so let's go back and look at our run download async and just see what changes we've made. First, we've made it an asynchronous method. And then we said it has to return a type task. Now the one more thing I didn't point out, but it's actually a really important convention that you really should follow. And that is you always append async to any method that's going to return asynchronously. Now, in our case, we had sync, and so async kind of made sense, but the reality is normally it'd be run download and run download async. So just make sure you append async on the end, just to let everybody know this is actually an asynchronous method, not a synchronous one. All right, so we have async, return the task, type task, not type void. And we have the await keyword in here. And again, await keyword says, run this asynchronously, but wait for the results. Now you may be wondering, well, why would you do that? Because it seems like if you want to run something asynchronously, you shouldn't also wait for it. That kind of doesn't make sense. Remember our A, B, C, D task example? You know, if we're waiting for task B before you do C and D, what's the point? Why not just do it synchronously? And the point is that whatever caller calls this can go on with their work after calling this. Okay? At the very least, our user interface can get back to doing user interface work while this is running, even while we're waiting for it. So it kind of puts in the queue and says, okay, we're waiting for this. It's not done yet. So you go ahead and do your work. And then it goes, oh, you know what? I just got that results. I'll go ahead and process from here. And so it allows us to have a little bit of flexibility, a little bit of control back because it's running asynchronously. So all we did was wrap our call, the download website, in a run, task.run, have the open close paren, lambda expression, the actual command we were calling before, wrap the whole thing in parens for a task.run. That's it. Okay? Let's see what the difference is. Now remember, this is running asynchronously inside of our execute async click. Okay, now this right here is warning me. It's saying, hey, you're not awaiting for anything here. Therefore, it's going to continue on afterwards. I'm going to leave that for now because I want to show you what happens. But we'll get back to that warning and fix it. But for now, let's go ahead and run this. Now I'm going to execute my async first. Because remember, it takes a little bit longer the first time. So I want to have that time to be able to show you I can still move the window around. So let's click here, and now I can move around, and look at that. They're popping in, and I can move my thing around at the same time. But I want you to notice one other thing. Right here, total execution time, 2. And then after that, I have 6 websites that have been downloaded. So that's a little weird because it stopped my timer before it finished all this work. I'll show you why. Because we never said, wait for this to be done. Therefore, it said, okay, it's a fire and forget. Call it. We're not worrying about it. Therefore, I continue on. We're going to stop the timer. We're going to give us a lap of milliseconds. We're going to write that out to the window, and we're all good to go. And this is where people usually panic and say, oh no, I've broken async away. I don't know how it's going to work. It doesn't work for my application because I can't just fire and forget these things. So what's going to go on? Well, don't worry. Okay, we're gonna fix this. All we're going to do is say, await. So we're going to wait for this. Now don't forget, whenever you do await, you have to do async. Now I'm not changing the method name here. And I'm not changing this from void. The reason why is because this is an event. Therefore, I don't change it from void. And I don't change the event name because it would break the event. I could go through and click async, but it's an event. So let's leave it alone. All right, let's try this again. And say execute async. Move it around, that's fine. They're popping in one at a time. There we go. Now let's run both of these over again just to see the time difference. So execute async again. That's 1364, 833, 1193, 854, somewhere around there. Execute normally, about a second, 7/10 a second, 1.1 seconds, 0.9 seconds. They're both executing about the same speed. Okay, so let's see if we can't get these tweaked a little bit to work at different speeds. So let's take advantage of this executing in parallel. Now the reason why they execute the same time or the same speed is because of this right here, the await. What we're doing is we're calling the first website and saying download that, but wait for it. Okay? Now, that's what it does is it blocks this particular method from getting to the next website until this first one's downloaded. And then it goes to the next one, and it blocks until the next one is downloaded. So let's solve this by actually copying this method. And we'll create a new version of it. Let's minimize that one down. We'll call this one run download parallel async. So it's going to do all these tasks in parallel instead of in sequence and await each one. Okay, so let's create a list of type task of type website data model. All right, and we'll call this tasks. So that's a pretty complicated list. Let's look at it. So it's at the very heart of it, we've got this website data model, and that's what's returned from this download website. But remember that if you don't await it, it returns a task of type website data model, which is this right here. And I'm saying I want a list of those because I have a list of websites I want to download. So now let's get rid of this line right here where we report on something, and we'll get rid of the await. And now we have this where it returns a task of website data model. We have this list of task of website data model. So it's going to say tasks right here, tasks.add, and add that one task. So what this is it's saying, I've got this bit of work, this kind of this bubble of work that I'm gonna do, or I'm trying to do, or I'm working on, but it's not done yet. And so it's gonna put this in a list. So we have a list of these little bubbles of work, these little pieces, and they're all running at the same time. And then at the end of this, I'm gonna have this list of all these sets of tasks that are running or have completed. All right, so what I'm gonna do down here is say var results equals await task.whenAll. So what the whenAll does is says, I'm gonna pass in some tasks, a whole set of them. Whether it be, 1 or 100. And you just wait until all of them are done. And when they're all done, then I want you to pass those results back into this results variable. So that results variable is actually an array of website data model. Now I'm more of a fan of a list instead of an array, but that's not a big deal because for each still works on it. So I'm going to say for each item in results. And what is item? Item dot, there's the website data and the URL. So now I can use that method we have, report website info. So I can grab a copy of that and come down here and say report website info for item. So you see the difference here? Before, up here, we're saying do this task and wait for it. And then do the next task and wait for it. Which works, and it's asynchronous, which allows the user interface to get control back and allows us to show that line one at a time instead of all at once. But it still meant that we're waiting the length of the sum of the download times. So, if each of them takes 3 seconds and there's 6 of them, that's 18 seconds worth of download time. Whereas here what we're doing is saying, okay, I've got a list, I want you to download it. Next one, download it. Next one, download it. And all we're doing is grabbing that task back and saying, here's this little bubble of work. It's already churning away, downloading that website. Just kind of hold on to it. We're putting those bubbles of work in this tasks list. Then we're saying, you know what? When all of them are done, grab the results of all of them, loop through them, and report. So what it's going to do is it's going to kind of wait to show us until they're all done, but they'll execute much faster. Okay, so there's going to be a little bit of downside in this method. And in fact, there is a way to have the best of both worlds, but that's for the next async video I do, where you do some more advanced stuff like reporting back from an asynchronous method into your user interface, which could be a little complicated, but I'll break it down for you. But that's not in this video. So just know that, for this, we're going to kind of lose some of our one at a time showing it off kind of thing, but we are going to gain some speed by doing these all at once. So let's change our call up here in our event, execute async, from run download async to run download parallel async. And let's run this again. And we'll do the normal, actually let's do the async execute now. Remember, it downloads slow the first time. Let's click it, and boom, it's done. Total execution time, remember this is slow, at 789. Let's do it again. 385, 379, 293, 373. Let's do normal. 792, 1100, 1000, 800, 793. Async, 247, 262, 241. So you see the difference there? We got that speed boost now because each of these websites is downloading at the same time. That means, in general, we're waiting for the longest website to download, the slowest one. So I don't know, maybe it's Yahoo. Yahoo looks pretty big. It's got 219,000 characters. Well, Stack Overflow has 256,000. So probably one of these two is the one we're waiting on. And so these other ones may have been done and parked. They're just waiting until, these two come back. And once both of them come back, then the whole thing is done. Versus everybody waits for this whole thing to get done. Then you go on to this next one, and this next one, this next one, this next one. You wait for this whole thing to get done before you're done the whole thing. That's why normal execution time takes, 1,000, 1,100 milliseconds versus half that time or less, a third that time. So as you can see, there's a big difference right away in my application. So let's recap what we've learned so far. First of all, the basic keywords you hear a lot, the ones we have to deal with are async and await. Async marks a method to say this is an asynchronous application or asynchronous method. And the await is what we use to say wait on something. Wait on some kind of asynchronous method. And the reason we use that await is because if we don't, then we're just going to fire and forget it and go on to the next step, which is what we had when we saw that the timer was written first. Because the timer continued on while this was downloading the websites. So we had to say, nope, wait for that. But even though we're waiting for something, it still gives control back to the user interface so that we can move it around, we can see other things pop up, other things could happen. In fact, we could even have other events kicked off or other tasks done by the user while they're waiting for this to complete. So it really does make much more use of your operating system, much more use of your hardware, of your computer, because it can do a whole lot of work and yet still give the users the experience of a responsive application. No one wants to have an application where they can't touch anything while something's running. It just kind of locks up. It may even turn gray. You got the spinny wheel or the hourglass, something like that. That's just not fun. So this way, just saying async and await allows us to avoid that. But then we also have the idea of running in parallel, where we're doing multiple tasks and then saying, hey, when all of them are done, then go ahead and move on. In this case, await for all of these, and then afterwards, print out the results. Now, the one thing I mentioned earlier that I kind of, not made up, but I kind of demonstrated how you could do it when you can't touch a method, is this task.run. So task.run wraps around a call to make it asynchronous when it's not asynchronous. But in this case, we do have the option down here in the download string to change that over to an asynchronous call. So what I could do is I could change this. Let's copy it and paste it. And this time I'm going to say download website async. And I'll make this call right here, download string to download string task async. And I will await it. And then finally I can make this method asynchronous and return a task of type website data model. Don't forget to change it to task. And why task? Well, remember when we return back an asynchronous method, but just say keep going, we want to have that whole bubble where we're saying, I have this, it's working, it's running, and I'm moving on, but I'm holding on to that so that later when it's done, I can do something with it. And that's why we have to have it be a task. So that's a task of type website data model. So I'm using the built-in that they gave me, task async. So that's great. All I need to do then is come up here to my run download parallel and change this to, instead of task.run, I can just take that out and say, this is the website download, or download website async. That's it. So since it's already asynchronous, now I don't have to do that task.run stuff. I just need to pass that into my list. So it works the same way. We run the async execution, boom. It still works just like before. It's just that I don't have to do that task.run. So that's if you have control over the method and can make it asynchronous natively, that's great, and go ahead and do that. But if not, don't despair. You can just wrap it in a task.run, and then you're good to go. So a little more of a complicated subject in some ways, just because you got to kind of think about what's happening and plan for, do I need to make this async? Do I need to make the next level up async? Do I need to wait something or not wait something? But the basics are, whenever you have an await, you should make it the method async. You have to make the method async. When you make the method async, you should change it from whatever output it is to an output of task of that type. So task just on its own if you're returning void, or task of string, task of your model, whatever. So those are the big things to remember when it comes to asynchronous. And then, do you want to await something or not await something? You don't have to await something, but just remember, if you don't wait it, it's going to, first it'll return a type task of whatever output you wanted. And second, it's going to allow your code to keep going, just like it did with our stopwatch. It kept going, and it hit the stop and gave us the elapsed milliseconds of 2 milliseconds, which sounds great, except for the fact that that's not actually how long it took. It's just that's how long it took to fire us off and keep going. So when to use await is whenever you need to rely on that data coming back, or use that data coming back, or your application shouldn't go on until it has that data. That's when you use the await. All right. So async, await, we have task, and that's about it for asynchronous programming. It really is that easy. There's no worrying about apartment models or threading context and context switching and all the rest of the stuff that we used to deal with. A lot of that's wrapped up in just async, await, and task. Those three things. So if you see some examples online where you use some of that more complicated stuff, don't worry. A lot of that's kind of hidden behind the scenes using this just async and await. I hope you found this valuable. Like I said, there is a part 2 coming that'll be the more advanced stuff, like canceling a task mid-task, and also getting some information back out of the task once it's running. So some status updates, that kind of thing. So I'll have that more advanced video for you in the future. In the meantime, I love if you leave a comment below and let me know what you think. And if you have any questions that you'd like to answer in that second video, if it's not out yet by the time you see this, go ahead and leave those in the comments down below as well. And I'll try and get back to those and respond to those in the next video. All right. Also in the description is a link to my mailing list. If you want to be alerted to some of my paid courses and the discounts that only mailing list people get, then definitely go ahead and get on the mailing list. All right. Thanks so much, and I'll see you later.